So in this lecture we will try to learn a few questions, to solve a few questions about domain. Okay, so we will look at a few questions, and by solving them we will also try to understand the concepts. So we should start with our first question. So the question is, f of x is x by root under x square minus 3x plus 2. Okay, so this is a function and we want to find the domain of this function. Okay, so domain of a function is the set of values of x for which this is defined. Okay, set of values of x for which f of x is defined. Okay, so now we know that okay, this is defined square root only when this part inside the root, if it is, this part is greater than equal to 0. Okay, so our first condition is x square minus 3x plus 2 should be greater than equal to 0 for square root to be defined. Okay, so this is the first problem or the condition. But the second condition is that the denominator should never be equal to 0. So this means this will be 0 if and only if x square minus 3x plus 2 is equal to 0. So we have to get the intersection of both of them for getting the domain. So intersection of 1 and 2 will become x square minus 3x plus 2 is greater than 0. Okay, so now we have to solve this equation, inequality basically. So if we factorize it, so x minus 2, x minus 1 is greater than 0. Okay, we can factorize this like this. Now what we do, if you get something like this, so just draw a number line, get the values of x for which this is 0. So we know that it is 0 for 1 and 2. Now what you need to do, just check that okay, in this side what is the value. Okay, so if let's say x is 3, so 3 minus 2 is 1, 3 minus 1 is 2, so positive, so this one is greater than 0. So now we can directly say that okay, this one will be negative, this will be positive, it alternates. Okay, so what happens, so in this case, so our result will be now this part and this part, so it will be minus infinity to 1 union 2 to plus infinity. So this will be the answer for our problem. Okay, so the things to remember is that inside the square root the expression should be greater than equal to 0. Second one is in the rational function, so denominator should never be equal to 0. So taking these two conditions and solving this inequality, so we get this as the answer. Let's look at next question. Okay, so log to base 10 root x minus 4 plus root 6 minus x. Okay, so this is the question. So now this is the question, you have to find the domain of this function. So again, to find the domain, so if we have to find the domain of fx plus minus g of x, so domain of this will be domain of f of x intersection with domain of g of x. Okay, so if we take this step, so we find that okay, so for this finding the domain of this, So this rule we apply because this is, if we take it as fx, this we take as gx, then the domain of fx plus gx will be the intersection of the domain of fx and gx, because these are the values of x for which both of them are defined, and our function is having both these functions in the expression, okay, in the definition. So fx is defined when what? So a square root is defined when inside the square root there is positive number. So x minus 4 should be greater than equal to 0, implies x should be greater than equal to 4. For this one gx, so 6 minus x should be greater than equal to 0, or x minus 6 should be less than equal to 0, or x is less than equal to 6. Okay, so this is the case. Next, what happens? We have to also see that we have a function log of fx to the base 10, okay, or f dash, something like f1x. So this is defined only when f of log is defined for fx is greater than 0, okay, f1x is greater than 0. So it means what? Now this whole expression should be greater than 0, isn't it? So if we see, so this square root of some positive number will also be positive, okay, and square root of this is also positive. So we know that, okay, this whole thing root under x minus 4 plus root under 6 minus x will always be greater than 0. So this means this is valid, and hence the domain of this is x is greater than equal to 4 and x is less than equal to 6, which can be written as 4 to 6. Okay, this is the taking the 4 included. Okay, so this is the interval representation. So this was about the second question, from which we learned this concept, that domain of fx plus gx is domain of fx intersection domain of gx, and then for log of some f1x is valid only if f1x is greater than 0 and a should not be equal to 1. Okay, so next let's see